Section 5.3 covers the mole, molar mass, and percent by mass. Now the mole and molar mass are review, and so you'll want to see section 2.4 through 2.6, and there's a whole video on this where we talked about the mole, and we looked at what does it mean to be molar mass. This unit really only reminds you of it because it's going to be so vital to chapter 5. But then it also goes on and introduces something called mass percent. So just kind of to remind you, what is the mole? What is molar mass? Molar mass means if you were to weigh out 1 mole of that element, how much would it weigh? Same way as when you weigh out 10, or I think we weighed out in this case 20 M&Ms. If they're plain, they have 1 mass. If they're peanut, they have another mass. It just depends on, the structure of it. It's the same thing with atoms. If you have 1 atom of hydrogen versus 1 atom of nitrogen, they weigh different amounts because they are different sizes. And so it's that molar mass that's going to be so pivotal to chapter 5 understanding. So let's go ahead and review it just slightly. So when we wanted to calculate the molar mass of sugar, the C12H22O11, when we did that, what you did was you took carbon and you found the molar mass, which was this number underneath carbon, and there are 12 carbon atoms. So you took 12.0107 times 12 to give you 144. Then you do the same thing for hydrogen. Its mass is 1.00794, but there are 22 hydrogen atoms in sucrose. And so then you multiply 1.00794 times 22 to give you this 22 number. Same for oxygen. Oxygen weighs 15.9994 times the 11 oxygen atoms to give you 175. Then to give you the molar mass of this entire sucrose molecule, you would just add those 3 masses together to give you 342.29 grams per mole. And so that's just how you calculate molar mass. It doesn't matter what type of atom it is, what type of molecule it is. What matters is that you look at the individual molar masses of all the components and you add them all together. Alright, taking into account how many of each atom type you have. So that's molar mass. I know I went through that really quickly, so if you need to, like I said, go back and look at those prior lecture videos. Or go read your textbook some more on this one. Alright, but then going forward, how do we use molar mass to figure out what these percent by mass calculations are? And so an example of this would say, what is the percent by mass carbon for sucrose? And so the idea behind this is, if you look at the whole sucrose molecule, what percentage of that mass comes from carbon atoms? What percentage comes from hydrogen? What percentage comes from oxygen? And if you add up each of those percent by masses, they should equal 100. Okay, it's just a pie chart. Some parts carbon, some parts hydrogen, some parts oxygen. Whole thing should equal the whole. Okay, but when we're doing this, it's the same idea. You've got carbon, and we know its mass, and you've got sucrose, and you know its mass, and it's just representing it as a percentage. Okay, so we've got percent by mass C equals the mass of carbon, and this is all of the carbons inside of the compound, over the mass of sucrose. So it should look like 12 carbons, since there's 12 carbons in the molecule, times 12.0107 over the whole mass of the whole thing. And you'll notice if you go back here, this is the same thing as saying 144, that's the part, over the whole 342. That's all we're doing, is we're saying, hey, what percent by mass is carbon over the whole compound? And so then you would just type that in, that 144 number divided by 342 times 100 with units of percent, and you get 42.1% carbon. Same calculations for hydrogen. This time though, you use hydrogen's molecular mass, and you also remember the fact that there are 22 hydrogens. So it's this number here is 22 times its mass over the whole mass of the whole compound. That gives us a percent by mass of hydrogen of only 6.5. And see, this is where I think it's non-intuitive for chemists, because chemists might look at it and say, but there's 22 hydrogens and only 12 carbons. Why doesn't that weigh more? It's the same thing as saying you've got 12 cars and 22 mice. Why do the 12 cars weigh more? Well, carbon weighs more. Okay, so you would expect it to contribute more to the mass of the molecule. One last calculation to perform. What is the percent by mass oxygen for sucrose? Same concepts. You've got the mass of oxygen over the mass of the total. So once again, we have 11 oxygens. The mass is 15.9994. Divide by the mass of the whole compound gives us a percent by mass of oxygen of 51.4. And if we look and we add up all of these percent by masses that we just calculate, you'll notice they add together to be about 100%. Now you can do these percent by mass calculations for any molecule out there. It's just coming through and methodically saying, how many elements do I have? What's the mass of that element? Divide by the total molar mass. But you have to know how to calculate that molar mass first. So before you move on to the next section, which is section 5.4, you need to make sure you know how to calculate molar mass. Do not go forward until you figure this out and become very good at it.